have a rod of uniform linear mass density which is lying on a horizontal frictionless surface. Force F is applied in this direction at a distance L/4 from this end. We are asked, that is there any point on this rod of zero acceleration? We have to find that point. Before we attempt this question, we know, that is, if there is a body of radius r revolving about O with the angular velocity, so these points, various points, all the points on the periphery or all the points onto this body, they are going to some acceleration. If this angular velocity is constant, all the points, they will have only centripetal acceleration. That is, if you are interested about this, so it is going to be r omega square. That is r omega square. Centripetal acceleration this way, for this r omega square this way, for this is towards center, r omega square this way, for this r omega square this way. That is, we had done in circular motion also, that is v square upon r, that is centripetal acceleration, v is equal to r omega. When we put over here, so it comes out to be r omega its whole square by r, that is centripetal acceleration comes out to be omega square into r towards center. Now it is quite possible that this body may not be just in uniform circular motion. Omega may not be constant. When omega is changing, it means this is non-uniform circular motion. If this is non-uniform circular motion, it means the A tangential will be there, the alpha will be there. Alpha is rate of change of angular velocity. When alpha is there, so it means AT is also there. So this has some alpha also. If it has some alpha, so this is equal to r alpha, tangential acceleration r alpha, and tangential acceleration r alpha. Apart from this, at this instant if we are talking about, that is, if it has angular velocity omega, the centripetal acceleration will obviously be there. That is, r omega square will be this way, r omega square will be this way, r omega square will be this way for this point, and r omega square for towards center for this point. When this is non-uniform circular motion, then obviously for every point we are going to have two accelerations. One is tangential, the other is centripetal. We have done in circular motion also. Now what if this center of mass is also pulled with, let's say, with the acceleration center of mass, or let's say we simply call it as A. Then what is the acceleration of all these points as seen by a person on the ground? What is the acceleration this person will see of this point? What is the acceleration of this point? And what is the acceleration of all these points as seen by this person? So if center is moving with the acceleration A, then we simply add this acceleration to all the points. That is, acceleration of this point as seen by this will be this vector sum of this, and add one more acceleration, this. For this, now it will be one is r omega square this way, r alpha this way, and the other is acceleration, that is center of mass, that is with which acceleration this is being pulled. For this, add one more acceleration, A this way. For this, add one more acceleration this way. So the net acceleration of this point is going to be this and this, they are in same direction, and this is at angle of 90 degree. We can find the vector sum, it is going to be somewhere in this direction. We can find the vector sum of all these accelerations. Similarly over here, r omega square is this way, A is this way. We can find the net acceleration along x-axis. This is acceleration along y-axis. So the vector addition of all these accelerations will give us the net acceleration of this point. Similarly over here, three accelerations. By vector addition method, we can find the net acceleration. So coming back to this, when F is being applied onto this, so now coming to the original question. If F is being applied onto this, whether you apply F over here or at center of mass over here, if we are looking from the top, this is lying on a horizontal frictionless surface, and we are looking from the top, so the equation of linear mechanics is F is equal to m into acceleration of center of mass. Whether you apply force over here or you apply force over here or center of mass, acceleration of center of mass is going to be F by m. As you change the distance of this force from center of mass, as you change its location, its alpha will change. It will have effect on its alpha. The alpha may be more or less. Like if you apply F over here at the center of mass only, so this rod will have only pure translation this way. This will have acceleration only. This will not have any alpha. But now this force is being acted over here, and we are looking for top. So if this is L by 4, the total length is L, mass is m, so it means this is also L by 4. So this rod will rotate about this axis with some alpha. So what is the torque? The torque of this force about C. we are interested in finding the torque of force F about C. What is that? Force into the perpendicular distance between line of force and axis of rotation, that is L by 4. So F into L by 4 is the torque of force about C, but torque is equal to I alpha is equal to I about C only. That is what? That is for rod, ICM is about this axis we have done, that is ml square by 12 into alpha. So from here we can get the value of alpha. So F L by 4 into 12 over ml square is equal to alpha. L and square that goes off, 4 and 12 that makes 3. So 3F by ml is equal to alpha. Now about this point when it is rotating like this, so let's say this point which is at a distance x from here, from center of mass, because of this alpha, this will have a tangential acceleration that is equal to x alpha. This is going to be there. Apart from this, because of force is applied, so center of mass will be moving with this acceleration. ACM is equal to F by m. So the net acceleration of this is going to be AT is equal to R alpha because of this, plus that is ACM is in this direction, that is ACM. If this and this accelerations, they are equal and certainly they are opposite also, so the net vector will become out to be equal to 0. So AT, that is X alpha, should become equal to ACM. ACM is what? F by m. What is alpha? Alpha for this body, rotating body, is that is X into, we put the value of alpha over here, that is 3F by ml is equal to F by m. F and F get cancelled, M and M they get cancelled. So X comes out to be L by 3. So at a distance X is equal to L by 3, this point will have zero acceleration.